Hello friends, this is Wael Bashwari, math and physics teacher. In this video I'm going to solve some questions that are important for sequence or arithmetic and geometric progressions for grade 9 and grade 10 in Sabis curriculum. So I'm gonna focus on some top questions like question number 33 about sequence. But before we start solving the question, let me give you an idea about the rules or the laws that are important in solving these questions. First one is arithmetic progression. An is equal to a1 plus n minus 1 times d. A1 is the first term, d is the common difference. So this is the first term and this is the common difference. And n is the term number. So n is the term number. So what about now geometric progression? GP an is equal to a1 r to the power of n minus 1. Same thing here. We have a1 is the first term and r is the common ratio. To see an example about this, we can, for example, look at sequence f in the beginning here. You have 7, 21, 63, 189. You can easily notice that if you divide 21 by 7, you get 3. And if you divide 63 by 21, you get 3. And if you divide 189 by 63, you get 3. This is called the common ratio, R. So this is the common ratio of the sequence. The common ratio is denoted by R. So now to find the term number 5, we can use this equation here to find the term number 5 or the fifth term. So you can see a5 is equal to a1, which is 7, multiplied by r, which is 3, to the power of 5 minus 1, which is 4. So 7 times 3 to the power of 4, 7 times 81, you get 567. So let's write it here, 567. So the nth term can be written as, if you replace 7 here, so you get 7 times the common ratio, which is 3, to the power of n minus 1. That is the nth term for this sequence. How can you check your answer? If you plug 1, if you replace 1 in n, you must get 7. If you replace 2, you must get 21. If you replace 3, you must get 63, and so on. Okay, for sequence L, you have 4, 15, 26, 37. Now, here we have to find either common ratio or common difference. If you divide 15 by 4, you get 3.75, but 26 by 15, you get different numbers. So, obviously, this is not a geometric progression. Let's check whether it's an arithmetic progression. If you subtract 15 minus 4, you get 11. 26 minus 15, you get 11. 37 minus 26, you get 11. This means this is an arithmetic progression. And in arithmetic progression, we have to use the first equation. So for example, if I want to find the term number 5, the fifth term, I can say a5 is equal to a1, which is 4, plus 5 minus 1 times the common difference, which is 11. And if you calculate that, you get 48. So here you write 48. Now for the nth term, you can do an is equal to 4 plus n minus 1 times 11. And then you simplify this. 4 plus 11n minus 11, which means 11n minus 7. So here you have to write 11n minus 7. For sequence y now, we have sequence y consists of fractions, and each fraction consists of a numerator and denominator. If you look at the numerator, you can find it 1, 3, 5, 7. This is an arithmetic sequence with common difference 2. So if you use the same logic, you can write the formula as 2n minus 1. And the bottom is also an arithmetic sequence consisting of first term 4, 4, 5, 6, 7. This is n plus 3. And then if you plug 5 here and here to calculate the fifth term, you can find that the fifth term is 9 over 8. Now for sequence u, we have the sequence as 4, 7, 12, 19. Let's see now the difference. The first difference, what is it? 7 minus 4, you get 3. 12 minus 7, you get 5. 19 minus 12, you get 7. This is the first difference. What about now the second difference? For the second difference, now it's very clear that the second difference is 2. So if the second difference is constant, this means the sequence is a quadratic sequence. And the formula for a quadratic sequence, Tn is equal to an squared plus bn plus c. Now, our target is to find ABC. We have a very important rule for the quadratic sequence. The second difference is equal to 2a. That's the rule that you have to use in order to find the nth term for the quadratic sequence. So here we say that the second difference, which is 2, is equal to 2a, and this means a is equal to 1. Like this, we have found a. Now we have to find b and c. So let's replace a in the equation. So we get Tn is equal to 1n squared plus bn plus c. Now we write Tn is equal to, let's take any value and replace it in Tn. For example, if I choose the first term and place it here, so 4 is equal to 1 times 1 squared, because this is the first term, plus b times 1 plus c. And if you reduce this equation, you can write it as b plus c is equal to 3. And then let's take the second term and replace it. 7 here. So now we get a new equation. 7 is equal to 1 times 2 squared, 2 because this is the second term, plus b times 2 plus c. Now let's reduce this equation, simplify it. 7 is equal to 4 plus 2b plus c. Now we can write it 2b plus c is equal to 3. Now let's solve these two equations simultaneously and see what we get. Now to solve these two equations simultaneously, this one and this one, the easiest way here is to subtract both equations. So let's do subtraction and see what we get. B minus 2b, you get negative b. C minus c is cancelled. 3 minus 3 is 0. And this means b equal 0. If you replace b in 0 in one of the equations, you get c equal 3. So finally, like this, we got the nth term, a equal 1, b equal 0, and c equal 3. So Tn in this case would be n squared plus 3. To check whether this equation is right or wrong, we have to replace the numbers and see, replace the terms in the equation and see whether we get the same sequence or not. So if you replace 1 here, 1 squared plus 3, you get 4. This is correct. If you replace 2, you must get 7. 2 squared 4 plus 3, you get 7. 3 squared 9 plus 3, you get 12. So this means that is the formula for this sequence. So here we write n squared plus 3. N squared plus 3. If I want to get the fifth term, for example, 5 squared is 25 plus 3 is 28. Like this, we solved question number 33.